Fail.
Are you listening?
Hey guys, welcome back to Theorem, and today we'll be talking about the work energy theorem / principle. Energy is one of the most important concepts in science, but there isn't one given definition for it. We define energy as the ability to do work, and from there, the closest definition to energy is a moving object can do work on another object it strikes. An example, like a flying cannonball does work on a brick wall that it hits. In many cases, moving objects exert a force on a second object which goes through a displacement. An object in motion has the ability to do work, thus can, say, have energy. Energy in motion is called kinetic energy. The general equations for kinetic energy are work net, which is work total, equals force net times the displacement. Another equation is force total or force net equals ma, which is basically our name. F equals m, bam. And then the other one's kinetic energy equals 1/2 mass times. Another equation is kinetic energy equals 1/2 mass times velocity squared. The work energy principle roughly is like the net work done on an object is equal to the change in the object's kinetic energy. This is only valid when work or the net work is done on an object. For Newton's law, if a positive net work is done on an object, the object's kinetic energy increases by the amount of W, which is the work. And the same goes for the negative. So if the negative net work is done on an object, the kinetic energy decreases. Kinetic energy is a scalar quantity. My bad. Alright, and so we're going to go over here for kinetic energy. The question is, how much net work is required to accelerate a 1,000 kilogram car from 20 meters to 30 meters? Okay, so in order to do this one, we have to use W equals K E, which KE2 minus KE1, which equals 1/2 mass times velocity 2 squared minus 1/2 mass times velocity 1 squared, which then equals 1/2 1,000 kilograms times 30 meters per second minus 1/2 1,000 kilograms times 20 meters per second squared for both. And then we get 2.5 times 10 to the 5th power joules. And now for the second part, we have gravitational potential energy. This is the most common form of potential energy. It's relative to the Earth's position. So it's like saying everything that's falling down is due to the Earth's gravity force. And the equation for that is PE, which is potential energy, equals mass times gravity times height. Okay, our question for potential energy is a 1,000 kilogram roller coaster car moves from point 1 to point 2 and then to point 3. What is the gravitational potential energy at point 2 and point 3 relative to point 1? Okay, we're going to use PE equals mgh, where h is 10 meters. So it's going to look like, so we multiply 1,000 kilograms times 9.8 meters per second squared times 10, which gives us 9.8 times 10 to the 4th joules. And then that was from point 2. So point 3 equals h equals 15 meters. negative 15 meters because it's going down. So it's below 0.1. And then same equation, PE equals mgh, where mass is 1,000 times 9.8 times negative 15, which then equals negative 1.5 times 10 to the 5th power joules. Alright, and that's all.